So we will discuss a rectangular plate element with 12 degrees of freedom, which is also a C1 continuity element, which we have with different types of elements used in plate analysis, C2, C1 and C0 elements. So if the rectangular plate has got 12 degrees of freedom, that means 3 degrees of freedom at each node. So there are 4 nodes, 1, 2, 3, 4, with the coordinates x1, y1, x2, y2, etc. like that. So if they are having 3 degrees of freedom at each node in a C1 continuity element, so these are the 3 degrees of freedom at each node. W is the displacement in z direction, as you know, W is the displacement in z direction, and derivative of W with respect to x and derivative of W with respect to y at different nodes, where I stands for the node. If you put I is equal to 1, 2, 3, 4 like that, there are 4 nodes here. W1, dou W by dou x at 1, dou W by dou y at 1, like that we can have 12 degrees of freedom, 12 unknowns, we can say 12 unknowns to solve. So that can be written like this. So di can be written as nodal displacements, in this case can be written as W, dou W by dou x, dou W by dou y. So totally there are 4 nodes, therefore totally we will be having 3 into 4 degrees of freedom. So W is a function of x and y. Now when you are assuming the displacement model, so displacement model W, we have to refer this Pascal triangle which I had explained earlier. It should be symmetrical with respect to both x and y. So the terms you have to choose in the displacement model or function should be in such a way that it should be symmetrical with respect to both x and y. So in this case, the displacement model or function W is in the z direction. It is assumed like this: alpha 1 plus alpha 2x plus alpha 3y. So these are symmetrical about x and y. Then alpha 4 x square, alpha 5 xy, alpha 6 y square. So these 3 terms correspond to second order. These 2 terms correspond to first order. First one is a constant. Plus next third order we have to go. In third order we have to take 4 terms, because here first term becomes x cube, second term becomes x square y, one x is reduced, one y is increased, third term becomes x y square, fourth term becomes y cube. So this is the displacement model you can assume for a 12 degree of freedom rectangular plate element. So there should be 12 coordinates, generalized coordinates, alpha 1, alpha 2, alpha 3, etc. up to alpha 12. Yeah, so here up to alpha 12 you will be having 12 degrees of freedom. Of course, the last 2 terms they represent the fourth order, x cube y and x y cube, because it should be symmetrical. You cannot take x power 4 here. So to have 4 degree x cube y and x y cube should be considered. This I have explained when I explained about the Pascal triangle while writing the displacement model. Now this can be written in matrix form like this: W is equal to P into alpha, where alpha is this alpha 1, alpha 2, alpha 3, etc. in the column vector form. That means it is a 12 cross 1 vector. Then P is nothing but this 1 xy like that up to xy cube. So this is actually 1 cross 12. So there is 1 row and 12 columns, and there is 12 rows and 1 column. So when you multiply these two, 1 cross 1 by 1 cross 1, you are going to get 1 cross 1. So 1 cross 1 is a single number, single value. So that is W. So W is written as P into alpha. Now from this assumed displacement function, you can get the derivatives also. Dou W by dou x and dou W by dou y you can get. So dou W by dou x is nothing but the rotation in x direction. Dou W by dou y is nothing but rotation along about the y direction. Now if you differentiate this partially with respect to x, you are going to get that first term dou W by dou x by taking y constant. And if you differentiate the same W with respect to y by taking x as constant, you are going to get the theta y term. Now once you get these three, so this is equation 1, equation 2, equation 3, these are the 3 degrees of freedom at each node point. Now substituting the values of xy as x1, y1, x2, y2, x3, y3, x4, y4 in all the four nodes, substituting for xy in the four nodes in these three equations and rearranging the terms. So for example, in the first node you will be having w1 theta x1 theta y1. So please note that here w1 represents the displacement in the z direction at node 1 and theta x1 is nothing but dou w by dou x at node 1. Theta y1 is nothing but dou w by dou y at node 1. Similarly, at node 2 you have w2 theta x2 and theta y2, and at node 3 you have w3 theta x3 and theta y3, and at node 4 you have w theta x4 and theta y4. So like this. So the total you have 12 degrees of freedom. So these are the now at this thing. So you can write this as in matrix form. After substituting all these things, you can write it in matrix form. So here, once you get these values w1, theta x1, all those things, so you can just write this matrix as a column vector like this. This first 3 corresponds to node 1, second 3 corresponds to node 2, third 3 corresponds to node 3, and the last 3 corresponds to node 4. And correspondingly, you can write the alpha matrix, which is written on the right hand side. And you will be having a 12 cross 12 matrix here. You can observe here, this is 12 cross 1, and this is also 12 cross 1. So when you multiply 12 cross 12 matrix with 12 cross 1 matrix, you are going to get 12 cross 1 matrix only. And here, from this, what you can write here is this delta L. So these are the coefficient matrix. 12 cross 12 I have not written here. But once you get this set of equations, 12 equations will be there, those coefficients. For example, coefficient of alpha 1 you have to write first, coefficient of alpha 2 you have to write second, like that for w1. So you have to fill this 12 cross 12 matrix. Then this can be written as delta E, that is the E stands for the elemental node. So you can or you can call it as delta I also. So delta delta E I will call because E stands for element. So there are four nodes here. So 12 degrees of freedom are there. So delta E is equal to this matrix I call it as G, coefficient matrix, into alpha. So therefore alpha is unknown. So alpha is G inverse into delta E. So alpha is found out using this. Alpha is found out using this equation. Then displacement within the element, any element P, X, Y, Z can be found out using this expression. W is equal to P into alpha. So W is the displacement at any point P within the element. Now the curvatures also can be found out. So curvatures I have told you that Kx, Ky, Kxy, they are the curvatures, and corresponding definitions of those curvatures are Kx is minus dou square W by dou x square, Ky is minus W dou square W by dou y square, Kxy is minus 2 times dou square W by dou x dou y. So once you know these functions, W is a function of x and y, you can find out the second derivative, and those second derivatives with a negative sign gives the curvatures, 3 types of curvatures in the case of plate element. So this is the explanation for a rectangular plate element with 12 degrees of freedom. Now on similar lines, you can have rectangular element with 16 degrees of freedom. So in the case of 16 degrees of freedom, you have 4 nodes. So at each node you will be having 4 degrees of freedom. So and these equations which we have written for 12 degree of freedom rectangular plate element, on similar lines you can write the equations or expressions for the 16 degree of freedom rectangular plate element. Now in this case it will be something like this. I will just give the sketch. It is similar to the 12 degree of freedom element. Only difference is at each node you will be having 4. You will be having 4 degrees of freedom. So this is x, this is y, this is z. So along this z direction, w is taken. That is the vertical deflection. Z is vertical axis, and you have the rectangular element something like this. You have like this. So this is, there are 4 nodes here. 1, 2, 3, 4. 4 nodes are there, and at each node you will be having 4 degrees of freedom. So 4 degrees of freedom. Those 4 degrees of freedom are 4 DOF at each node. So here what happens? So there are Wi, dou W by dou X of I, dou W by dou Y of I, and the fourth one. So these 3 we are going to take in the case of 12 degree of freedom rectangular plate element. In addition to this, you will be having dou square W by dou X dou Y also of I. So total you have 4. 1, 2, 3, 4 degree of freedom at each node. I stands for the node number. So there are 4 nodes, therefore 4 into 4 you will be having 16 degree of freedom. Here also you will be having the coordinates of the nodal points with respect to origin as x1, y1, x2, y2, x3, y3 and x4, y4. And here if you proceed on the same lines which we have done, so the thing is we have to assume the displacement function in this case using Pascal triangle as we did in the case of 12 degree of freedom rectangular plate element. So it should contain totally 16 alpha terms, 16 generalized coordinate terms we should have in the case of the displacement function. So I can write here the displacement model for 16 degree of freedom rectangular plate element now becomes, I can write like this. See, W is equal to alpha 1 plus alpha 2x plus alpha 3y plus alpha 4x square plus alpha 5xy plus alpha 6y square plus alpha 7x cube plus alpha 8x square y. See here, it is third order, plus alpha 9xy square plus alpha 10y cube. So third order is over. Next fourth order, this is by using Pascal triangle. In the fourth order we have to take alpha 11 x power 4. Alpha 11 x power 4 we have to take. See, plus continue. Alpha 11 x power 4 plus alpha 12 x square y square plus alpha 13 xy cube. Xy cube. These are all fourth order terms plus alpha 14. I will take x cube y square, that is fifth order, plus alpha 15 x square y cube, plus lastly sixth term alpha sixth order alpha 16 x cube y cube. See, this I have written using the concept of Pascal triangle. So it is very important. I had explained earlier. You can observe here there are totally 16 terms. One term for each degree of freedom. The first one is constant, second and third term it is linear, that is order is 1. Then fourth, fifth, sixth, seventh terms order is 3. Then you have up from alpha 8 to alpha 10, 3 terms are there which is of the order 4. So x square y which is of the order 3 only. One second, sorry, this is this one. From here it is 3. From here, yeah. So here what happens, from up to this y square term, that is second order. This third order starts here, up to that. Then fourth order from here to here, fourth order. Then fifth order is only 2 terms. Then sixth order. See, so first order 2 terms are there. This is constant term. Second order you have 3 terms. Third order you have 4 terms. Fourth order you have 3 terms. Fifth order you have 2 terms. Then lastly 1 term. So, is also symmetric. You can see here 1, 2, 3, 4. Then 3, 2, 1. Like that it will come. So this is the displacement model for a 16 degree of freedom rectangular plate element. So similarly, what we can write here is W is equal to P into alpha, which I had explained in the last 12 degree of freedom 4 noded element. On similar lines, you can write like this. So here only thing is this P is nothing but the matrix 1, x, y, etc. up to this last term x cube, y cube. So this is a 1 cross 16 matrix, and alpha can be written as alpha 1, alpha 2, alpha 3, etc. up to alpha 16. So this is 16 cross 1. This order of this is 16 cross 1. So now what happens? This is P is 1 cross 16, alpha is 16 cross 1. If you multiply these two, you will get 1 cross 1. So this is 1 cross 1 single number. So that is the displacement in z direction. Here also we have to differentiate this. This you can take it as 1, equation 1. So by differentiating that 1, you will get dou w by, with respect to x, you will get dou w by w, that is theta x term you are going to get. You can call this as 2 by treating y as constant. Differentiated that partially with respect to y, theta y you are going to get. You can call it as treating x as constant. You can call it as 3. Now once again, substituting for xy values at the 4 nodes in equations 1, 2, 3, and if you rearrange the terms here also, so what you will get here, w1, theta x1, theta x2 like that, and you will be having 4, so theta x1, theta y1, then theta xy1. So please note that this theta xy1 is this is theta xy1. So this is theta x1, this is theta x, this is theta y, this is theta xy. So there is additional term we are going to get. So more accurate results we are going to get. This is for one node. Similarly, you have for second node w2, theta x2, theta y2, theta xy2 like that for the second node, and it continues for the third and fourth node also. W3, theta x3, theta y3, theta xy3. Then for fourth node, W4, theta x4, theta y4, theta xy4. So totally you will be having 16 elements in this column vector, and once again you will be getting is equal to, instead of 12 cross 12, you will be getting 16 cross 16. That is the coefficient matrix you are going to get, and finally here you will be having that alpha 1, alpha 2, alpha 3 general coordinates up to alpha 16. So now once again this can be written as W is equal to G into, or this can be written as delta E. I will write as delta E. So delta E is this one, delta E, this 16 cross 1 matrix, and this is G matrix into this G matrix is coefficient matrix into alpha. So you are going to get like this, or if you want alpha general coordinate matrix, it is G inverse into delta E. So this is how we can get the coefficient general coordinate matrix. Then afterwards, after getting this alpha matrix, we can find out the displacement at any point P within the element. So here, similar to the last one, so P is x, y, z. So within the element, by putting the values of x, y, z and all, so at any point P, you can find out W using this P into alpha. Because alpha is known now from this, so alpha is found out. So from this alpha, we can find out the displacement at any point in the plate element. So this is how we can do the analysis of a 16 degree of freedom rectangular plate element with 4 nodes. Taking 4 degree of freedom at each node, we can analyze like this.